E here is, I would actually classify this as somewhat deceptive. And what I mean by that is this just looks so much like an arcsine integral. And after having spent some time on arcsine integrals or inverse sines, and then also like all the integrals on this study guide are like they're all they come from all over the place, right? But it's not an arcsine integral. What I need to do is look at this as a u, and then figure out a du that'll match that. And the reason why I do that is because I got x squared in the bottom here, and then that guy that I pointed out up there is a, oops, this guy is a multiple of the derivative of x squared. So I'm going to let u equal 4, minus x squared. That makes du equal to minus 2x. If I divide by 2 and multiply by 3, which gives me 3 over negative 2, then I get 3 over 2 negative 2 du equals 3x. Notice I've got this here, and I've got this here. So my sub is going to be that this is equal to the integral. I'm going to put this term out front, so that gives me a minus 3 over 2, sort of looks like a 3, of du over root u, which I'm going to rewrite as minus 3 over 2 integral of, you might know this integral boom off the bat, right? And you should know that 1 over 2 root u is the derivative of root u, so this should take us to a positive root u, or a multiple of it. But go ahead and do it out. I get u to the negative 2, whoops, 1/2 du, which gives me, bump it up, I'll write my minus 3 over 2, and then times, if I bump the power up from negative 1/2, that takes me to u to the positive 1/2, and then I multiply by the inverse of this function, or the flipped version of this function, so I get times 2 over 1. These two are going to cancel. Write my plus c. That gives me minus 3 root u plus c, which is going to be minus 3. I'm going to sub that u back in. Root of 4 minus x squared plus c. Now, I mentioned in the beginning that this right here is deceptive because it looks like arcsine. See if you can write what you think the arcsine would be, the arcsine version of this. How would I get an arcsine, or what would I have to change about this to make it an arcsine? I would need integral of 3 over root 4 minus x squared. I just basically need to get rid of this. I don't need to have a 3. I could have any coefficient up there because I can always pull it out to the front of the integral. But that's the difference. Hopefully you can recognize this versus this.